So we're going to look at sort of two definitions today and how they're related to what we've been doing. But we're not looking at equations of lines necessarily today. There will be a little bit of talk about equations, but not developing equations like we've done. But like I said, we'll come back to that tomorrow. Okay. So first we want to look at these definitions. We've talked about parallel lines before, and you know this word very well, I think, parallel. It has all kinds of applications. Just growing up, you hear that word here and there, right? Parallel lines are lines that always have the same distance between them, and when they run side by side, they never cross. So you can think about a nice town where all the streets are square and grid-like. Like if you drive around Kitchener, all the streets curve, and King Street and Weber Street cross each other like 3 times. It's ridiculous. But in a nice neighborhood where everything is square, you have 2 streets that are running north-south. Those would be parallel. They don't cross. Streets can be parallel for a while and then turn, obviously. And in mathematics, this is a strict definition, though, right? So 2 lines that are parallel will never cross by definition. Okay, we all know that? Have you heard of this word before? Yes, some of you have? Everybody has? Some. I wonder if some of you haven't. Maybe everybody has. So perpendicular. Again, by definition, this is an important, very important definition. In fact, both of these will come up every year in mathematics. We talk in different ways about parallel lines and perpendicular lines. Perpendicular lines are lines that meet at a 90-degree angle. Okay? So that's something you need to know, what the word perpendicular means. But the next thing that we need to know is, what does this have to do with the stuff that we've been talking about? So there's slopes. Now we've, I think, talked about this, and probably a lot of you can make this connection on your own. Consider 2 parallel lines. What is true of their slopes? What has to be true of the slopes of 2 lines that are parallel? How many people think they know? Think about it. Don't just wait. Think about it. Look at that diagram. Do you believe that those 2 lines are parallel? Lines can look parallel and not be parallel. So in mathematics, we do this to show that lines are parallel. So those lines are parallel. What is true of their slopes? What do you think? They're the same. So this is what's true. They must have equal slopes. Let's write this down. And if their slopes are equal, they will be parallel. So it goes both directions. If they're parallel, they have the same slope. If you find that they have the same slope, then they are parallel. So we write it like, so if a slope equals A, then a slope that's parallel, this is how we write that. That's not the number 11, that's a symbol for parallel, is also A. Okay, or if a slope is AB, then a slope that's parallel will be A over B. Let's take a look at this example. I'm going to call this line A and this line B. You don't have to write this down, don't have to draw this. I just want you to watch. And again, this is how I would show this. What is the slope of line A? So I find a point, and you could use the slope formula, but if you have the graph, you just count. Okay? Find another point. I went up 2 and over 1. Rise over run, 2 over 1. Is that a positive or a negative slope? Positive, because it's running this direction. So this is positive 2 over 1, which is 2. What about this one? Well, I'll pick this point, and I'll pick this point. So this is a rise of 1, 2, 3, 4, 5, 6. So slope of line B is 6, and it was a run of 1, 2, 3 to get to this point that's directly below. Well, what do we notice about 6 over 3? Positive as well, obviously, right? 6 divided by 3 is also 2. If you reduce this fraction, you get 2 over 1. But 6 divided by 3 is 2, so the slope is 2. So then we say since slope, this is the symbol for since, right? Slope of A is slope of B. Line A is parallel to line B. This is how we would say this. Okay, questions? Folks, this is important. If you come into class tomorrow and you forget that parallel lines mean same slope, you're going to be in trouble. It's not on the quiz, not for that reason, but just you have to remember this, okay? This is a very important idea. All right. Next, perpendicular lines. It's not as obvious what is true of two lines are perpendicular. But it tells us right here, so you want to write this down. You don't have to draw the graph. You can just look at the graph. When two lines are perpendicular, then the slope of one of the lines is the negative reciprocal of the other, and vice versa. The technical definition of that means their product is equal to -1, but don't worry about that. I want you to remember the term negative reciprocal. Have you heard that term before? No? Okay, I wouldn't have thought so. It's not hard. It's easy, I think. But this is the other thing you have to remember. If you can remember these two things, perpendicular lines, their slope is the negative reciprocal. That means meeting at a right angle. Parallel lines, their slopes are equal. What does negative reciprocal mean? Well, what does reciprocal mean? Flip. Reciprocal sounds like a fraction that we're flipping. What does negative mean? It means negative. Take the negative of it. If it's positive, switch it to negative. If it was already negative, switch it back to positive. So you flip the sign and flip the fraction. So in other words, if my slope is, whoops, not capital A, is A over B, then a perpendicular slope, which we would show like that, will be what? Does anybody want to guess? Say again? You got half of it? Negative B over A. Good. And that's what negative reciprocal means. Everybody okay with that? Again, I'm going to ask you to just watch, and I'll show you some thinking with the little diagram. But I'm going to go back up here. There was one thing I forgot to show. Like, think about parallel lines. And if I go up 2 over 1, for them to not cross, this has to do the same thing to keep that distance. Like, it just makes sense that their slopes would be equal, right? Because if this one goes up 3 over 1, it's going to be getting closer every time. Or if it goes up 2 over 3 instead of up 2 over 1, it's getting farther away. So they're not going to be parallel. So if you think about the rise and the run, this sort of step that we can do with slope, it makes sense. Well, how about with perpendicular lines? Well, first of all, if one of them has a positive slope and they are perpendicular, which we would show like this, doesn't it make sense that the other one has to be sloping the other way? It's going to be the negative. I think that makes sense. And again, if I look at this line, 2 points, I go up 2 over 1. For this one, I go up 1 over 2. So it flips. and otherwise it's got the same numbers, and one's positive and one's negative. So again, I'm going to go line A, line B, and I'm going to say the slope of line A was up 2 over 1, which is 2, and the slope of line B, I'm going to do it again, up 2 over 4, and it's negative. If I reduce this, I get negative 1 over 2. 2 over 1, negative reciprocal, negative 1 over 2. So slope of A is the negative reciprocal of B. So line A is perpendicular to line B is how I would show that. Okay, so very quickly, a little bit of practice just with perpendicular lines, perpendicular slopes. Write the slope of a line that's perpendicular to some other line that has a slope of 4. You can do it if you want. Try it. You're going to write it like this. What's the answer? Who can answer it? Negative 1 over 4. So the slope of 4 is like 4 over 1. We always know that. See how useful that idea is? I told you a long time ago. The fact that you have a whole number, if you need it to be a fraction, it's over 1. It comes up over and over and over again. So I take the negative reciprocal, I flip the fraction, and change the sign. So what if my slope, original slope, is negative 3? That's like, yeah, it's going to be, so that's like a slope of negative 3 over 1, right? So the perpendicular will be positive 1 over 3. Good? You do the next two? So for C, what's my slope going to be? Negative 2 over 1, which is negative 2. So if you wrote it either way, that's fine. Write it like this. Always a good idea to simplify it to that. But this is how I would think of it as my first step, right? Very good. And the last one? Somebody else? Positive 5 over 2. Awesome. Okay, so now that we've got that established, some other kinds of questions to practice. So this is talking about lines, but not like not coming up with equations. It's just saying state the slope of a line that is parallel and one that is perpendicular to each of these three lines. Okay, are we ready to start A? So my first question that I'll ask to you, but that also you would ask to yourself, do we know the slope of this line? Why do we know it? Very good. Exactly the answer I was looking for. Because it's in y equals mx plus b form. So what is the slope of this line? Just 3. Good. So a slope that is parallel and a slope that is perpendicular. This is how I would want you to show your work. State the original slope first. I know it seems ridiculous because the parallel line is just the same, but like this is how we want you to show it. Okay, so state the original slope first. A parallel slope is going to be? And perpendicular will be? Negative. Not just -3. What's the other part to it? 1/3. Yeah. So flip it, right? Yeah, good. Okay, B. State the slope. State a slope that's parallel. Trivial, but state a slope that's perpendicular. Go ahead and try it yourself. So the slope of this line, again, why do we know? We already know the slope of this line, don't we? Because it's in y equals mx plus b form. You have to do that thinking every time, though, which means the slope is 1/4. Parallel slope, same. Perpendicular will be +4. Very good. Okay, and C is a little bit different, you can tell. So what's going on with C? It's in standard form. And what's important is it's not in y equals mx plus b form. So do we know the slope of this line? We do not. Some people might think, yeah, it's 3. No. It's not the coefficient of x if it's not in y equals mx plus b form. So what do we have to do? Yeah, why do you want to do that? Because we're putting it into y equals mx plus b form. So Muna's right. I could take the -4y over. I'm going to do it the other way just to show you what it would look like if you did it the other way, because we often make mistakes with negatives. So just to remind us how this would work, but you could do it either way. So I'm going to subtract 3x and subtract 3x. What's 0 minus 3x? -3x, right? And I'm left with -4y. And this is what people always mess up. Then you got to divide by -4. And do not do decimals. 2 negatives makes positive. Reduce the slope if you have to. Now this is in y equals mx plus b form. Now I can state the slope. A slope that's parallel. And a slope that's perpendicular. Flip the sign. Flip the fraction. I think we have one example left. Any questions? Determine whether the pair of lines is parallel, perpendicular, or neither. What do you think we do for this? There's a little bit of problem solving, and it's the kind of problem solving that we'll move into starting tomorrow. What do you think we do for this? Anybody have an idea? So when it's asking you about parallel and perpendicular lines, it's asking you about slopes, so shouldn't we find the slopes? Then we can just compare them. Some people might think, oh, if I find the equations, then I can look at the slopes. But you don't even need to find the equations. All you need to do is find the slope. because I don't really care about the y-intercept in this case. So very good. So we're going to do that. So line 1, and how are we going to find the slope? Slope formula. So go ahead and try that. You can do it for both lines. Okay, so I found both slopes. Slope of line 1 and slope of line 2. And you can already see what's happening here, but I'm going to show you a little bit of form stuff as well. This is what I want you to do. So slope of line 1 is that. Slope of line 2 is that. So slope of line 1, that's parallel, will be what? Just the same, right? -2. Slope of line 2, that's parallel, will just be the same, a half. Slope of line 1, that's perpendicular, will be 1/2, because this was -2, so I flip the sign, becomes positive, and flip the fraction, becomes 1/2. And slope of line 2, that's perpendicular, will be, flip the fraction, 1/2 becomes 2/1, change the sign. And then you can compare. And we do a therefore statement. We say since slope of line 1 equals slope of line 2 that's perpendicular, this slope equals that slope. Therefore, line 1 is perpendicular to line 2. These statements seem a little like overkill for this process because it's kind of simple, but this notation is notation that becomes quite important in grade 10, and like moving forward, this is how we write things in mathematics, so it's good to get used to. So try to do it this way as best as you can. Another note that we might not be as picky about in grade 9, but next year they will be. Slopes are not perpendicular to each other, lines are perpendicular to each other. Okay? So I wouldn't say slope 1 is perpendicular to slope 2. This is why I'm saying it this way. Slope 1 is equal to the slope that's perpendicular to line 2. Slopes are negative reciprocals of each other. Lines are perpendicular to each other. Technical definition stuff, but it is one that we make a distinction on.